Let me take you through the second question that requires the knowledge of views of squares, square roots, and reciprocal tables to evaluate the following. One thing of concern from the question is that we are going to express our answer to 2 decimal places. Over to the solution. Let's keep our question intact. This question requires that you find the square root of 34.46 and the square of 8.67. Then you can proceed with the rest. I will do a demonstration of finding the square root of 34.46 only. Our square root table is divided into 2 sections. One section is for square roots of numbers between 1 and less than 10, and then the other one are square roots of numbers from 10 to less than 100. We are lucky that 34.46 is encompassed in what the table provides, so we are not going to do anything apart from reading. This is how a typical table of square roots looks like. We have a column headed X. Then we have another column, we call it the main column, that has values running from 0 to 9 here. And then we have the last one, we call it the mean differences column here, that runs from 1 to 9. So these are the 3 main divisions in the mathematical table. There will always be a column headed X, there will be a main column, and there will be the mean differences column. So how do you treat 34.46 in terms of finding its square root? Under the column headed X, you locate where 34 is. So we have our 34. 34 is a whole row of values. So this row under which we've located 34, there are so many values there. Then the digits are 4. We have 34.46, so we've located already where 34 is. Then this 4 indicates the value in the main column, so we shall read something under this 4 here. And then 6 is located in the mean differences column, so under 6 we shall also read a value, and the value that we shall read, we shall add it to the very end of the value that we read. We shall also read from the main column rather. That's why this is showing add. So this is it. We have located 34, we have located 4, and we have located 6. So how do we use these values in order to get the square root of 34.46? So 34 under 4, we have a value written as 8652. How do we use it? If you look at 34 under the main column 0, there is a value there, 5.8310. What 5.8310 tells you is that the square root of 34.0 is 5.8310. However, I have highlighted the yellow. That means this way, that the 5 point is used across. Instead of writing 5 point everywhere, the 5 point is written there, but the understanding is that the 5 point is used across. So when you say 34.4, it is going to be 5 point, then you take the value under 4, is 8652. So that is the square root of 34.4. Then under the mean differences column, the value is 51. This 51 is added to the very end of the value that we've read. So 2 added to 1 gives you 3. 5 added to 5 is 10. 0 carry 1. Then you have that as 7. And then you have that as 8. And then you have 5. So the square root of 34.46 read from mathematical tables is 5.8703. However, we always write our answer to 4 significant figures. So the first significant figure, the second, the third, the fourth. If there is anything extra, take whatever is ahead of it, round off. 3 cannot affect our 0 because it will only be affected by values that are 5 and above, so we shall have our square root as 5.870. You shall do the same in order to find the square of 8.67. That comes to 75.17. Then we can rewrite all this. You know, when you say, if someone tells you A over B, another way of rearranging it, because we are thinking of reciprocal, this can be rewritten as A times 1 over B. So we can rewrite this also as follows: 2 times 1 over 5.870 and 5 times 1 over 75.17. So we are meant to do reciprocal here. You know, when you say 1 over 5.870, it means the reciprocal of 5.870, and the same case applies for this one. However, when the value is more than 9.9999, because our table for reciprocals provides reciprocals of numbers between 1 and less than 10. So we'll need to write this in standard form, and that is it: 7.517 times 10 raised to power 1. I will include something here. This can be rewritten. 1 over 7.517 times 10 raised to power 1 can be rewritten, and I want to illustrate this way. If you give me A over B times C, I can rewrite this as A over B times 1 over C. So this is a way of rearranging it. This is a way of rearranging it. And the goodness is that we have 1, so this 1 can be shared among the 2 and will not affect the value. So we rewrite this as 2 multiplied by the reciprocal of 5.870 plus 5 into 1 over 7.517 times 1 over 10 raised to power 1. Why have we used 1 twice here? It is because it is not going to affect our value. It is not going to affect our value. This 1 can be shared, but if it was a 2, you use the 2 on one of them and leave the other one, use it as 1. So this one is okay. We then move. Now the next task is to read the reciprocals from mathematical tables. The only difference in reciprocals is that in the mean differences column, we don't add, we subtract. In the mean differences column, we shall do a subtraction. So let's get over and see what we are supposed to do. The reciprocal of 5.870 is 0.1704. That of 7.517 is 0.1331. I would suggest that you pause the video and go to your reciprocal tables and read out the reciprocals. In the mean differences column, you subtract. Then 1 over 10 raised to power 1. 10 raised to power 1 is just 10. 1 over 10 is 0.1. Then carry out the multiplication. 2 times 0.1704 is 0.3408, and when you multiply the whole of this, you get 0.06655. When you sum up, you will find 0.40735. Remembering that once you read these values here, the values are given to 4 significant figures. This is where you do the 4 significant figure thing here. So here is just a multiplication. You add and then express your answer to 2 decimal places. After the decimal point, count 2 places to the right. 1, 2. Ahead of this, we have 7. 7 is a value that is in the category of 5 and above. So we round up the value behind it by adding a 1. And since this is 0, this comes to 1, so 0.41 is our answer.